Oh, and I forgot to mention, it's actually been running this whole time and it's up to temperature as we speak. You can hear it's making no noise right now. Hey everyone, welcome back to the channel. So in one of my previous videos, I asked my viewers if they wanted to see a fanless 3D printer build. So here it is. This is a PrintrBot simple metal. It was released about 7 years ago. This printer is pretty much an antique. It has a capped-on build plate because apparently that was cool back then. And it doesn't have any way to start a print. There's no touch screen or dial knob. Also, the stepper motor drivers are horrendously loud. And it uses an Hotend, which has since been discontinued. It only had 2 fans on it that could be easily removed. There's the part cooling fan and this ATX power supply. So I just took the part cooling fan off and replaced the ATX power supply with a power brick. So in order to modernize this printer, I bought a kit from BIGTREETECH, which has a touch screen, a board with silent stepper drivers. The stepper drivers are individually removable. So if I fry one from running it too hot, I can just pull this chip out and put a new one in. I'll be using my thermal camera in order to identify hot spots on the circuit board, and I'll be installing heat sinks in order to address those hot spots. I'm using the magnetic flexible build plate by FYSETC. You can tell they didn't cut any corners with it either. So I'm going to have to trim these myself in order to get it to be round. So now that I've introduced you to all the pieces of this puzzle, I'm going to start putting it together. I'm going to start by installing this heated bed sheet. Looks like I'll just have to do some minor trimming to get it to fit. After getting rid of the Kapton tape, I'll remove the sticker backing of this magnetic sheet and just put it on the board. These screws on the edge are kind of interfering, so I'm going to cut notches out for the screws on either side. Alright, and that fits perfectly. So before we start modifying the electronics, I want to show you what we're working with. So we have a direct drive extruder right here, an Hotend, a metal detecting bed leveling probe. For our Y-axis motion, we have the stepper driver here, which is driving a belt, and the Y-axis is riding on these 2 rails. The rails are supported by 4 bearings that are pressed into these metal blocks. This lead screw moves the Z-axis up and down, and it's driven by a stepper motor that's underneath this plate. On the underside, you can see the belt that moves the X-axis, so that moves the table back and forth, and it's driven by this stepper motor that's located in the back of this machine. The build tray is heated, and it's supported by 4 linear bearings. So you can see there's no fans down here, which kind of surprised me. These are the stepper drivers, and you can see none of the stepper drivers have heat sinks. So now I'm going to start taking all the electronics out and putting the new stuff in. The kit that I got came with an extra stepper driver that I could put over here if I wanted to drive like a second extruder or something. But since I don't need this, and I might be frying one of these circuit boards, I'm going to just keep this as a spare. I decided to mount the board over here instead. It's just getting difficult to fit everything underneath the machine. So it took a while, but I finally got it wired up. And I have my firmware loaded. I'm just going to try and turn it on for the first time. I don't know how I got it to switch over to this, but that's good news. We're in business. Alright, so we'll test this puppy out. I'll plug in this up here. So it still says Nathan Builds, so somehow I was able to install that firmware. Ooh.
Today we're going to get started on...
Alright, so let's go over all the improvements I added to this machine. We've got our spring steel build sheet, which I can remove and flex the parts off of easily. We got our BLTouch sensor. I had to replace the original inductive one because it was kind of an outdated design. I put a filament runout detector on here. I figure at least one of my machines should have a filament runout sensor so it can eat all of my almost empty spools of filament. And the electronics and user interface are all new. Originally this had no user interface and I had to plug a computer in to run anything. but now it has a screen that I can set up as a normal 3D printer interface, or I can actually set this up as a touchscreen if I want to. This new control board is an SKR 1.4 Turbo from BIGTREETECH, and it offers a lot of advantages over the original board. First and most importantly, it has silent stepper drivers, so I won't hear this thing screeching whenever it's printing. Additionally, these stepper drivers have something called sensorless homing, so it doesn't need limit switches to zero out the X and Y axes anymore. It's also got a bunch of extra plugs up here that'll allow me to attach extra accessories, such as the filament runout sensor, the BLTouch, and anything else I want to add. Oh, and I forgot to mention, it's actually been running this whole time and it's up to temperature as we speak. One of the most unique features about this machine is it's completely fanless, so you can hear it's making no noise right now. This FLIR sensor is one of the most important tools that I'm using in this project, because it'll allow me to see if anything's going to be overheating since I'll be running it without a fan. Right now everything looks cool, but we'll monitor it while we're printing too. I don't have any way to mount my filament runout sensor right now, so I'm just going to put a zip tie in it to keep it from stopping the print. It took me about 20 hours to figure out how to edit the firmware and get this working, but I think it was worth it because with what I learned I should be able to reprogram my Ender 3 machines as well. Editing the firmware is a lot of work, but once you figure it out, it opens up a whole lot of opportunities for you to be able to modify and reprogram your 3D printer. So now I'm going to run the Z-Probe wizard, which should help me set the right probe offset on my machine. So it looks like it's just having me touch down the nozzle. If you get this wrong, you can scratch up your bed, so just be careful with this step. Alright, so now I think I'm ready to run a print. Let me go slice something really quick and I'll be right back and we'll test the machine out. The way this is set up, it reads from the SD card that's attached to the screen. There's a micro SD port that's on the main board, but that's mainly used for flashing firmware. And you can reprogram that so you can also print off of that SD card. But I'm going to keep it set up this way because this full-size SD port is a lot easier to get to. So now it's time to print. We'll see what this thing can do. And this is actually my first ever Benchy, so hopefully it turns out good. Uh-oh. What? Okay, so I figured out what was wrong. I created a new profile in PersaSlicer, and it defaulted it to having some really fast velocity and acceleration limits for my Z-axis. So after reducing that, I think I should be able to run just fine now. So this isn't looking good at all. Alright, I'm gonna abort this. Alright, I slowed it down to 25% speed and turned off the heated bed. So we'll see if that helps keep the parts a little bit cooler. Alright, I'm going to let this run overnight, but before I do I want to take some decibel readings. So let's pull out the handy decibel meter. Yeah, this is definitely one of the quietest printers I've ever seen. It's staying under 40 decibels. The linear bearings are making some clicking noises, which is registering as little peaks like around 35. This isn't much louder than ambient noise. This is extremely quiet. So I did actually wire up a plug for a fan just in case I want to add one later. It doesn't affect the sound reading that much. So still the printer's operating sub 40 decibels, which is pretty amazing. When at a stock Ender 3 it ran around 60 decibels. After I upgraded all the fans it ran around 50 decibels. And now with this fanless build I'm getting under 40 decibels. If I want to speed up my prints I think I'm going to have to add a fan like this. But I'm going to leave the fan off for the rest of the print because I want to see how this Benchy turns out completely fanless. Alright, so we'll check back in on this thing tomorrow morning. Alright, so here's my first Benchy. You can see it's not bad. It actually finished. It could be better. For this next print, I added a part cooling fan, increased the temperature, and I'm printing at 4 times the speed of the last print. And with the first layer down, we'll turn on the part cooling fan and we'll check back in on this once it's done printing. So I decided to cut that test short. It wasn't turning out very well. I think what I'm running into is just the limitations of this old school hot end. It doesn't really extrude very well, and I think I'm just going to have to replace it. I'm going to conclude my testing by printing something a little easier than the Benchy, just to see if I can get good results on like kind of more square shaped things without overhangs and all that weird stuff. I'm going to print out another one of these screen covers because this one doesn't fit very well. So we'll get a practical part out of this and we'll see if we can do any better on the quality. As long as I avoid overhangs or bridging, this printer does a pretty good job. Whoever modeled this snuck some little 80-degree overhangs in over here, so those didn't turn out very well. But when I finish it, I'll trim it up and see if I can get it to look good. I'm also printing some Benchies on my other printers so I can compare them to the results on my Fanless machine. And now it's doing a really bad job of closing up this infill. But we'll let it run for a couple more layers and see if it can patch that up in the end. If we look at the electronics, it looks like the hottest parts of the board are the stepper drivers. So those are running about 50 degrees Celsius. 54. Those are getting pretty hot, but I wouldn't say that it's too hot. But the rest of the components are cool to the touch. Now that this print is finished, I can test out the spring steel heated bed. Works pretty good. These parts ended up looking decent. The only part that's showing a lot of flaws is this overhang area. That's a pretty steep overhang, it's about 60 degrees. If I would have known that overhang was there, I probably would have cleaned this model up before printing it. So I might be able to clean this up with some post-processing. This is called the deburring tool. It's pretty handy for cleaning up jagged edges on 3D prints. My deburring tool also came with one of these to help clean up holes. And just to compare the Benchies, so this is the Benchy I produced on the Fanless machine, and you can see it's not very good quality. I think the extruder is really limiting how good of quality I can get out of it, because it oozes a lot, and it's got a really long melt zone, and if the extruder is starting and stopping a lot, it ends up with pretty bad quality. One of the problems with this UBIS hot end is the melt zone is really long, so there's molten plastic all the way from the tip up to about here. You can see when I pull this filament out, it's melting all the way up here. So that means there's molten plastic for this whole section. And that adds a lot of friction, so it's really hard to extrude plastic out of here with any level of precision. Being a first print, there's some problems, and there's some improvements that I want to make on this machine. So I'll be sure to revisit this one. This Benchy came off of my Ender 3 Pro with silent fans. But other than that, it's pretty much stock, so this is kind of the stock build quality you can get. And it's really nice. I have no complaints with it. This Benchy was printed at 200% scale on my Ender 3 V2 with a Volcano style hot end. Check out the video I did on how I made that machine. Alright, so I'd say this project was a success. I've built my Fanless 3D printer, and it's running as quiet as ever. I mean, you can hear the birds outside louder than this running 3D printer. But I've identified some weak points in this design. One of the main ones is this hot end. I plan on upgrading it with a modern heat block and a fanless heatsink of my own design. So make sure to subscribe to the channel and check back on these videos if you want to see how that's working out. This thing should be able to print a lot faster once I put the new hot end on, and I'll have crazy RGB lights and a custom heatsink, so you won't want to miss it. Also, one of my favorite party tricks I haven't shown you yet. This actually is powered by a cigarette lighter style car plug. So, being a 12-volt system, you can plug this directly into your car and run it while you're driving around. So I'm looking forward to trying that feature out later. So that's it for this episode. Make sure to smash that like button if you like this machine and want to see more of it. Hope you enjoyed this episode, and I'll see you in the next one.